Hello to everyone and welcome to our monthly mechanical engineering virtual meetup. My name is Anton Fedosiev and I'm the content strategist on customer success organization here at Autodesk. And the topic of this month is CAD to CAM. So knowing that most of you are probably in kind of design and roles with some exceptions, we wanted to talk about CAM a little bit. And we have Tim Paul from Fusion 360 product management team, and we have Guy Buttle and Andrew Ward from Autodesk Consulting to talk about some of the things that we have both in terms of like products and ways to learn the solutions that we have. Before we jump to the main agenda, let me talk about the webinar basics. So all the lines are currently muted on your side. This is to reduce the background noise because the session is recorded and will be provided to you in a couple of days from now on Customer Success portal. Also, if you have any questions, please type them in instantly, right? Because this is a meetup, this is live, and the goal is to have really meaningful conversations. So this is not one-way communication today. And also watch the chat because we will be dropping different links and resources in the chat window. Okay, so quick refresher about mechanical engineering meetups themselves. This is monthly series. It happens every second Thursday of each month, and we have a rotation of topics. And we have interesting and different speakers every month. But something that does not change is the cadence. Every second Thursday of each month. And the agenda is pretty typical. So we have representatives from product management team to update you on what's going on with the product, and different experts sharing their best practices with the group here. And also we have similar virtual meetups for other typical professions in CAD industry, such as architects, BIM managers, plant designers, etc. So today's webinar, like last slide, I promise from my side. So the typical situation with CAM, I know it varies, right? But many of you probably have one of these questions, right? I'd like to understand how to navigate among different offerings that Autodesk has. Then I didn't know that I have access to those solutions. Then if I knew that I have it, didn't know where to start, or I used it 10 years ago, I need a refresher, or I look for a comprehensive learning path or certification in CAM space. So we will try to address all of these 5 categories of questions today, and we'll start from the first one with Tim Paul. And since he represents product management team, I want to put the safe harbor statement here that if we talk about some future plans, they're subject to change, but of course, we're trying to provide accurate information. All right, Tim, it's all yours.
Yeah, thank you for that. So as it says there, I'm Tim Paul. Yeah, maybe if you can go to the next slide. Yeah, thanks. So I'm Tim Paul. I've been with Autodesk for about 5 years. I'm currently one of the product managers for the manufacturing tools in Fusion. Before coming to Autodesk, I was in the manufacturing industry for 15 years, where I used 7 different CAM tools while running my own business and managing different machine shops, ending at a major defense contractor before coming to Autodesk. I also write an article in CNC West magazine for anyone in the Western United States. You can find it around the middle of that. I came to Autodesk because I saw an opportunity to change the industry in a positive way. And I feel like we're delivering on that with the work we're doing with education and the tools that we're making more widely available than ever before. So next slide. So we maintain a powerful core functionality in CAM across both Inventor and the Fusion platform. This slide shows some of the functionality that is in both platforms. from 2.5 to 3-axis milling to turning, water laser plasma cutting, some probing functionality. I think the easiest to use indexed, 3+2, 3+1 type of milling. We also have a wrapped 4-axis toolpath in there. And then we have a little bit of multi-axis milling as well. This is the same tech that I fell in love with as a customer while managing the machine shop for a large aerospace company before I came to Autodesk, and it's still, I believe, the core platform to success for many shops. So next slide. So in an effort to increase development velocity, we've recently shifted our focus from developing CAM tools for multiple platforms with Inventor and HSMWorks and Fusion to the single Fusion platform. This will allow us to more quickly bring advanced technology to Autodesk customers. Much of the development efforts you'll see in Fusion in the short term will leverage what we've learned with our power teams like the PowerMill, PowerShape, PowerInspect teams. These will be the things you'll see in the advanced functionality will be things like multi-axis milling, deeper probing functionality, things like that. So next slide. So our main focus on development is in Fusion. Inventor continues to see updates. Beyond updates, we'll bring over new development as it makes sense. And we'll also be working on building bridges that will allow a seamless workflow from Inventor to Fusion to leverage the more advanced manufacturing tools. This slide shows some of the progress we've made recently in building those bridges. We're working on an open in Fusion kind of experience. The progress we've made will allow you to open in Fusion and leverage existing tools from your tool library, posts, and machines. What we're working on now is, what we will be working on next will allow you to start in Inventor and then jump over to Fusion while bringing over your toolpaths and your setups. So that's pretty basic. In summary, our main focus to increase the velocity of how fast we can bring new tech to market is we're focusing on one platform, and we'll leverage kind of keeping up with parity as we can. But for now, our focus is to make a really good experience when jumping from Inventor to Fusion and back. So it's pretty short and sweet. I'm happy to stick around and answer questions if they come up.
Yeah, and the most frequently asked question, team, and thank you for giving this update, is what you mentioned. Does it mean that Inventor CAM is not important, not supported, or it's still supported and it will be maintained in its current state?
Yep.
Yeah, so to recap, Inventor CAM is not going out of the market. It remains there. It will be in the current supported state for quite a while, and existing customers can still use it.
Yeah, perfect.
Okay, so excellent. Thank you for the update, team. And with that, we'd like to kind of talk a little bit about where to get started, right? Because I mean, CAM is it's a like big manufacturing in general. It's a huge domain. There are a lot of things to keep in mind, lots of things to learn, and in some cases it's overwhelming, right? But there are some fundamentals that don't change from product to product, and there are several ways from Autodesk to learn about it, and one of them is the course that we recently created with Guy. So I will let Guy to talk a little bit about the course that he created in a second. Hey, Guy.
Perfect. Great. Hi, everyone. I believe there's the next slide is a intro slide. Is that right? If we flick to the next slide, let me share my screen. Let's do that. Can everyone see my screen? We're all good?
Yep, we can.
Yep. Great. So I'm Guy. I'm an implementation consultant with Autodesk Global Consulting Delivery. I'm based out of Birmingham in the UK, where we have one of our advanced manufacturing facilities. Came to Autodesk through the Delcam acquisition. I worked for Delcam as an intern while I was at university, and then joined Autodesk full time in 2018. Have worked kind of in various different areas of the business, consulting, pre-sales, marketing, and I'm now settled in consulting, dealing kind of mainly with Fusion 360 and the power products, our PowerMill, PowerShape, Power Inspect, that kind of thing. Today, what I am looking to talk to you about is the courses that we have that we've come up with that aim to sort of give designers, give mechanical engineers a bit more of an overview of manufacturing, machining in general. Machining is obviously such a broad subject, as is designing components, but they both go very much hand in hand. It's all well and good creating pretty pictures on a screen, creating components that look great, but if they can't be manufactured, then there isn't really much use to them. Our course that we came up with aims to kind of give you some of the basics. What I'm going to be covering in the next couple of slides is talking to you about kind of some of the basics of CNC machining, what to kind of keep in mind when designing components, everything from tooling, holders, looking at the feeds and speeds that the tools need to be run at to give you the best surface finishes, and to create the best components possible. So I'm going to split what I'm talking about into 4 parts. There are four different videos on the Learning Hub that we have access, very short bite-sized videos, just to give you some quick, easy information to help you when designing and creating components. The first that we'll be looking at is different types of CNC milling cutters, various geometries, shapes, sizes, what you'd use them for, when you'd use them. The second then looks at the cutting direction, speeds and feeds of those cutters. So which way should you run the tool? How fast should it move along the surface of the component? How fast should it spin in the spindle? Then moving on from that, looking at tool holders, why you'd use different tool holders, what their benefits are, when you'd use them with different tools, and then finally moving on to work holding. So you need to bear in mind when designing a component how you're actually going to hold that component on a machine. If you can't hold it on the machine, if you can't hold the material on the machine, you can't cut the material and you can't create your part. It's as simple as that. So our first video that we look at gives you an overview of kind of common cutters. Obviously, there are many different variations of cutters, but we look at why you would use given geometries, when they would be used, the materials that these cutters are made from. Some cutters are solid, some cutters are designed to have removable tips so that they can be replaced. So this video covers which you should use for which situation, to give you a bit more of an idea of how to design the geometry of your component with manufacture in mind. So it prevents that kind of wasted time in designing a component that is then sent down to the shop, and that component is then sent back up to the designer, as the machinist, the programmer can't program toolpaths to cut it correctly. So giving engineers and designers those tools to understand how components are machined will hopefully allow you to design your parts more efficiently and better. So the next video looks at the difference between climb and conventional milling, listing some of the pros and cons of why you would cut in one direction as opposed to another direction, and then looks at cutter feed rate versus cutter speed, and how you can find, as you can see in the diagram in the bottom corner, how you can find that sweet spot for certain geometries of components, certain materials, the processes that need to be followed and are best to be followed to give you a nice component at the end of the process. It then goes on to look at some of the other parameters that affect your feeds and speeds of a cutter, to give you an idea of what a machinist will be thinking about when a CAD model comes onto his computer ready to be machined. We then move on to look at tool holders. This is the third video. We look at different types of tool holders, with what type of tooling they should be used. Certain tool holders can be used with solid cutters of various different materials. HSS is high-speed steel. I should have probably put the full name on there. And some holders use tip cutters, as I spoke about earlier, tools that have indexable tips that allow you to cut with them and then replace them when they get worn down. The final video that we talk through is looking at work holding. Obviously, different types of components, different parts have different shapes, different sizes, and different types of material. And depending on these shapes and these sizes, various different types of work holding need to be considered, depending on the type of work holding that you'll be using will have an effect on how you design a component. Some types of work holding will need you to design a method of fixturing that component to the machine bed. Others will allow you, like you can see on the screen, to clamp around a cylinder or flat edges. So all of this needs to be considered when designing the component. So getting a base knowledge of these processes and these fundamentals, we think is really helpful for a designer, for a mechanical engineer, to help kind of close that gap between shop floor and design office, kind of closing that gap and preventing the need for just kind of blindly throwing the components over the wall down into the machine shop to be machined. There allows a bit more of a two-way communication between the designer and the manufacturer. And with that, I believe that is everything that I was hoping to speak to you about. Obviously open to questions at the end, but thanks for your time.
Thank you so much, Guy, for sharing the contents of your e-learning class. And I dropped the link in the chat window. Please take a look, click the link. So all the information that Guy shared is available as e-learning course or certificate in the end that you can use as your professional development hours. But also something else that I wanted to bring your attention to is the CNC handbook that we're providing both as a part of the e-learning course and here in the webinar. It's a huge PDF file, really well formatted, that goes kind of much deeper into fundamentals of CNC machining. This is something that does not change. And for many of you who took CNC or machining classes in university and college, there will be not much of new information, but for those of you who are more specialized in just the design part or have never used CAM, this is really great resource to understand all the basic information. It's available as download. Okay, so here we kind of finish our, let's call it like CNC fundamentals part, right? And move on to a little bit of software application. And this is where I'd like to give the stage to Andrew Ward, who will talk a little bit about Inventor CAM and how to navigate there and get things done in the product. And Andrew, the stage is yours, but before you jump to the demonstration, do you mind sharing a little bit about you and your history with Autodesk and CAM?
Sure, I've been working with Autodesk since 2013. Prior to that, I was in production management in a couple of large machine shops in New York, making various components for compressors, and actually involved a lot with the final drive of NASCAR gear trains. I got transferred to Autodesk when they acquired HSM. I was also involved in designing machines and actually building machinery in my last job in Inventor.
Excellent. So let's jump into this course that you created, the one that I also dropped the link in the chat window. So you walk the audience how to get this real part designed and manufactured, right? So what inspired this project, Andrew? So why did you pick this part? And
because it actually demonstrates the flexibility of having the CAM system within the CAD. Because as I was building this assembly, I was finding that I needed to make changes on the fly. And the way that the CAM works is it recognizes that there is a change in the CAD model. And so if anything, especially outside bought components, sometimes I would get a data sheet telling me, these are the sizes of this component, but when I actually got it, they were completely different. So I'd have to go in there and change the CAD model, which I can show you on the demonstration. And then as I would do that, then I could automatically update all the CAM processes and get the correct fit and function that I needed.
all right, then thank you, Andrew. And let's jump into the demonstration. And right after, we will talk about the kind of full certification path available from Autodesk in CAM and in Fusion 360. But before that, let's talk about Inventor CAM. All right, so let me make you a presenter.
Can you see my screen?
We can see your screen. Yes, the
Oh,
video
cool.
and the Inventor.
So this is where I started. I was designing equipment in industry, using Inventor every day. This was a cheese grater designed for Oscar Mayer for their Lunchable range. So when I came to Autodesk, I knew how to use Inventor, and somehow I accidentally fell into the trap of trying to make an electric guitar for myself. So the thing was modeled, and I started to try and make this thing on my CNC router. And just as a demonstration, I had this block of material. And as I was working on this, I was finding that I had to go into the component and directly edit some of the edges and the interfaces where I found components weren't fitting that I thought they would. I then went on into CAM processes. Found it extraordinarily easy to use. Things like setup of your stock model. I was used to in industry using all sorts of CAM systems, and things like orientation of the part on the machine was always so difficult and so convoluted. You know, just to switch the x-axis was a lot of dialog boxes and a lot of typing and putting in numbers. In this system, it's an easy switch. You can actually in the screen, you can pick on an axis, you can flip it around, you can define where the origin is of the component very, very easily. In this case, I picked a stock box point. In industry, I will be using a model origin, so I'm using the same origin as inspection. This is just a component for myself. I knew the size of the stock, so I could type that into the stock dialog box. There was a few things on the machine that I had to adjust for, so I could offset the bottom of the stock by a certain amount, which made life very, very easy. And then I went ahead and started doing processes like machining the top face. All of these operations are very intuitive. Every single one of these operations has basically the same tabs at the top, which you just fill out with all the data that you want to do. Most of the defaults give you decent toolpath immediately. There's no hunting around trying to get some toolpath. Most of these operations, if you pick a cutter and you pick the geometry, it will immediately start to give you toolpath. There's really, you know, it's very, very simple. And then I went ahead and did things like pocketing out this little shape here. First, go into the height selection dialog box where I can set all the heights for the different operations before the operation, the rapid to position, and then the bottom height where the cutter path should actually go to. So this is all very intuitive. In fact, you can actually go in here and you can pick on some of these heights and actually move them. So a lot of in scene operations where you can dynamically move things around. I also found when I was machining, especially on I've got a CNC router, a lot of times I would go about it not really knowing what the sequence of operations would be. I'm cutting wood. I'm really not used to cutting wood. And I found one of the best things was to be able to pick onto an operation once I'd done it and then move it to a different place. Because sometimes when you're actually cutting components, what you conceive would be the best method to do something, when you actually physically get to the machine, you'll find that you can't do it that way. Changing things like the things on the model, I found it was very simple. If I went into something like a whole operation or something like that, I could easily go in and change any of these positions, and then when I went into CAM, it would tell me automatically that I've got to update certain operations to continue. The interface basically is set up, which we just went through, and then you've got all your standard operations like drilling and facing, your two-dimensional milling, slotting, tracing, threading, and then you go on to the 3D milling, most of which are finishing operations. Most of the CAM systems I used in the past really skimped on the finishing operations and kind of left me a little bit cold. But this definitely has got a lot of options, and then onto multi-axis milling, which unfortunately I'm not able to do on my ShopBot. Once I've done all this, I found it was very easy to go into here and then create some code for my CNC router. And here I've got the ShopBot. So I pick the post processor from the post processor list. I give it a name. So when I load this onto the machine, I know exactly what I'm machining. There was lots of components for this guitar. And then you might have to give it a program number that the machine likes to see. Some of them are like a 5-digit number. And that'll be put in the header of the code, so the machine knows what to which slot to put it into its memory. And then it's just a case of hitting the post-process button, and there is the code that I would load into my CNC router. And when I was in industry, I used to be very skeptical about CAM systems, and I used to sit and read through this to make sure everything was correct. Now I'm using this in my own time. I've got to the point where I don't even look at this code. I just hit the button to post it, go and load it on the machine. I'm that confident that it's gonna cut the correct part. So after hours and hours of machining, that was the finished project. That was done in Inventor and Inventor CAM. So it does work.
This is fantastic, Andrew, that the fact that you know, you accomplished it. And actually, when we discussed the kind of data set or the model that we could use for the course, we decided to pick the guitar for many reasons. Of course, like it's Andrew's passion, but also we thought that it's something that many of you could produce as well if you are interested in CAM. And we even got the question that in the course we're providing just, you know, this little part, right? And we had the question like, can you share the full model? So is it something that is possible, Andrew? The model of the guitar? I don't want
I'd
to
have
put
to
you on the spot.
find out. I'd have to find out where if I could share it.
Yeah.
It's not proprietary. It's not proprietary, but I'd have to check.
Yeah.
I can give out a website that actually has the solid model, but you have to pay for it. It costs you $5.
Ah, okay, gotcha. All right. Well,
Not
at least
not to me. You don't pay $5 to me.
yeah, of course. But at least in the course, we're providing the parts that are custom, that are designed by you, right?
Sure, yes.
Okay, good. So with that, do you have anything else that you wanted to share, Andrew?
No, I'm good.
Good. All right. Let me take the control back to quickly summarize and kind of show you possible next steps. And then we'll jump into questions. We've got quite a few of them. So let's get ready. Like, okay, a recap on the next steps. And let me quickly cover it. So we spoke about a lot of things today, so it's not easy to remember, but we will send the summary, so hopefully it will be useful. So we have a bunch of courses that are available, not only about CAM, but in fact about more like typical how to design with intent, how to use the most powerful tools in Inventor Fusion itself. So it's everything on the same website, and we talk about these courses on monthly basis, but the focus of this month, of course, is CAM, right? So you can access, I highly encourage you to check out the learning content that we provided to you, but there are different levels, right? For getting started, what we spoke about today is perfect. but there is more. There is much more available from Autodesk, and let me quickly walk you through what's available. I'm gonna switch to online resources because, as always, to navigate in this complex world of online tech is kind of more content is not always better. So let me show you our top picks in this case. So this is the course that we spoke about today, Introduction CNC Fundamentals, and this is the course that Andrew demonstrated, CAM for Inventor users. To register on this website, you don't need to pay anything. You can use your Autodesk ID, the one that you use to download your software and manage your account. Just log in and take the courses, and in the end of the course, you'll be able to get the quick certificate of completion. So this is a good starting point. If you know much more about CAM, then of course, great reference is just simply using their documentation of the product that you use. If this is Inventor CAM, this is Inventor CAM reference where you can learn about certain features, or it's Fusion CAM, just help documentation that you can use to learn more about certain technology. But if you are interested in more like comprehensive curriculum, there is a lot of things that you can do on 2 of our resources from our certification team. So this is about the kind of having more comprehensive validation of what you know, right? And here on Design Academy, I will also drop the link in the chat. If you pick areas of study as manufacturing engineering, you get comprehensive curriculum, 20 hours long on different machining options that you have in Fusion 360, right? So introduction to CAM, CNC machining, 3-axis, lathe, and multi-axis CNC toolpath. All of them are like 20 hours long, and this puts you on the certification track, right? If you're interested in taking those courses on industry recognized website, then the same content is available on Coursera. So let me quickly find this learning path. This is Coursera. So this is neutral platform that has this great specialization from Autodesk about Autodesk CAD and CAM for manufacturing, right? So this is probably around 40, 60 hours long. And you get a certificate of completion from Coursera and from Autodesk. Really great course. Highly recommend you to take a look if you are interested in getting more like certification, big learning journey, right? And finally, for those of you who are experts in the field, there is always a way to learn. That's why I encourage you to check out what's available on Autodesk University, either to learn yourself, right? Look for classes that fit your specific need, search for the topic, pick the product that you need, or even if you are industry expert and you have a lot of things to share, we highly encourage you to become Autodesk University speaker this year because call for proposals is open. So go to AU website, submit your proposal, or vote for your favorite topic. So in November, you will be able to join this online conference and participate. So this is the kind of quick summary that I wanted to cover with all of you. I will drop the links to all of those resources in the chat. So watch them carefully. And with that, let's jump into Q&A. So please feel free to drop a message in the chat in Q&A panel or raise your hand. We can also unmute the line and have a conversation. Okay, so let's talk about PowerMill a little bit. We have a question about PowerMill and CAM portfolio. So we have, obviously, we covered Inventor CAM and Fusion CAM, which are, well, at some point they were very similar, and now the investment on Fusion side is higher. But what about the CAM solutions, how they're positioned with the Fusion CAM?
So the ex-Delcam products are, I would say they are much, some of the capabilities are much more high end. So for very complex 5-axis parts or surface design and surface modeling, and for inspection of components that need more than what is capable in Fusion and in Inventor at the moment. That is where the Delcam products are positioned. I'd say Inventor and Fusion are very much, they have their place in the market. They are very, very useful in closing that design to manufacture workflow, enabling you to create and manufacture something all in a single software. That's kind of the positioning for the very top end of each specific workspace, each specific workflow is where you would more likely use the PowerMill, PowerShape, PowerInspect.
Mm-hmm. This is great, and Guy, thank you so much for this answer. And the team, Andrew, any other thoughts from your side as well?
No.
Not really. I think the only thing I would add is that the power products, as we're focused on, getting some of that technology into Fusion, or a lot of that technology into Fusion, we're also kind of doing things that we've wanted to do to the power products for a long time. So some of those are benefiting. So some of the speed improvements and things like that, we've been able to push into both platforms.
Yeah, and the important consideration here is the entitlement, right? Of course, it's always possible to purchase new software, but the important aspect is when you simply go to manage.autodesk.com, this is your Autodesk account, right? The important thing is to check what you already have access to, either from yourself or from your company, right? That I'm trying to demonstrate it live, and of course it does not work. Let me use this one. Yeah, if I go to products and downloads, this is what I see, right? No, it's not loading. Sorry, I will not be able to show it live, but you get the list of all products that you have access to. This is good point to start, right? Just see what's already available to you without any need to purchase, and then you will be able to pick the right learning track depending on that. Okay, so let me quickly scan the list of questions, and probably a great one to pick from the list is, are there any specific setup routines for master CAM or kind of transition from master CAM?
I'll answer. Well, actually, I don't know if I have an answer for that. I'm not sure if I understand the setup routines, but we do have, having been a long time Mastercam user myself, I know that it can be challenging to transition from one tool to another. Speaking of the Inventor, the Fusion workflow, that's why we're really focused on, it should feel very recognizable when you go from one to the other. regarding the transition from something like Master CAM to Inventor CAM or Fusion. There is a transition guide. If you go into the Fusion website, there's some adoption content, and you should fairly easily be able to find the Master CAM transition guide for that. I hope that's somewhat helpful.
Yeah, this is great. And yeah, I was actually thinking about the same transitioning guide, because there are like many CAM products similar in many respects, right? So there's this transition guide that will help you to understand what are the matching commands and matching routines on Autodesk side if you use another product. Okay, so let's jump to the next question. Let's pick this one. What do you recommend for new CNC operators in terms of accreditation as a starting point for the shop to implement? So.
I was stalling to see if Andrew had any input.
Well, I don't know. I think it depends on the CNC machine, you know.
Yeah,
It really does.
So I'll say that's a big topic, but we can have a whole webinar on something like that. But let's say to Andrew's point, if you have a Haas machine, your Haas factory outlets have different controller training. They have machine training. A lot of them now are offering Autodesk CAM training. If some bigger shops are leveraging NIMS certifications, there's a lot of different options out there, and I don't want to make it sound like it's a beast, but having managed a lot of different shops myself, I've always kind of come up with my own what's important for the shop that we're at. So
yeah, but it looks like it can be categorized in several categories, right? One is kind of basic safety training considerations that are hardware independent, right? Then there is CAM related part, how to use CAM properly and how to use certain machines that you have on the shop floor properly. So those are kind of certifications that you need to probably consider and look case by case, right? Is that accurate?
yeah, that's a great point. Yeah.
Mm-hmm. Okay, so and kind of it's maybe let's go into this kind of hardware transition. We had two questions. One question is about in general, like, okay, we have CAD product, either Inventor or Fusion, we have CAM, but then you also need to connect it to the machine and have the proper setup in order to be able to control the machine and have the post-processor. What is the recommendation? Where to get those, post-processors and how to connect to machine? Does Autodesk provide something, or this is from machine manufacturers? So how to proceed there?
Well, there is a library of post processors that come with Inventor. There are a bunch of milling post processors, turning, mill turn, and cutting processes. So there is also a website for Autodesk CAM post processors where you can actually download certified and tested post processors for various machine tools. There's hundreds of them.
Mm-hmm.
Yeah, that list is growing longer and longer, and it's worth mentioning that a Fusion post, an HSM Works post, and Inventor CAM post are all interchangeable.
Yeah.
Okay, and the last question that is more specific, more like expert type, but it's a meetup, so let's discuss this more complex topic. So question from Dan is that he struggles with adaptive clearing. of the part from a much larger piece of stock, because most demos from Autodesk and other vendors tend to show stock that is like tiny bit larger than the part itself. So any thoughts on this kind of big stock
Yeah,
clearing?
I've not used adaptive clearing too much because I'm cutting wood, and what I tend to use is the 2D stuff. So I know I've got an idea. I can kind of forecast where it's going to enter and exit the wood because the wood grain. I need to know that. Adaptive, I can't really predict what's going to happen. So I don't have a lot of experience with the adaptive.
I've got a lot of experience with the adaptive, going from, when I had a real job before Autodesk all the way through Autodesk. And the question, so a lot of struggles with adaptive. So that's, we can break that into, is it a calculation time, topic? And sometimes, a 3D adaptive toolpath can just take time to calculate. There's some, computer. I saw another question pop up. I thought that was maybe an answer to that. So if it's a calculation issue, sometimes you just have to be patient and go work on the next toolpath. You can let it calculate while you're working on the next toolpath. Some people will try to keep their stay down. I should be fired. I'm forgetting a specific term, but they'll try to maximize their stay down distance. If you set it to most, it's like quadrupling the calculation time. So I usually find 60 to 70% is generally the most efficient on the machine, but it takes a little bit longer to calculate versus the least. Some people have just don't like the fact that it kind of moves around. So there's just a lot of different settings that you have to play with. There's a lot of good tutorials on YouTube about kind of dialing those in. So I'm not sure how helpful that answer is, but there's a lot of information out there, and without going over a specific example, it's going to be hard to pinpoint what the troubles are.
Yeah, and then feel free to respond to the recording to the email that you received from us. We may be able to follow up with your specific case. In the meantime, so let's take two more important questions, and then we'll summarize and close it out. Great questions. Thank you for joining and sending all of those. So first one is kind of Inventor and Inventor CAM. Those are kind of Inventor CAM. It works inside Inventor, right? But it's a separate product that you need to download from your Autodesk account. So if you have access to, if you're a commercial customer, you should have Autodesk Product Design and Manufacturing Collection or enterprise contract with Autodesk. Then you go to your account, you install Inventor CAM as a separate line, and then you get those tools that Andrew showed inside Inventor, right? If you are education customer, you also go to the student portal, you search for Inventor CAM, install it, and then you get those extra buttons inside Inventor. Or you use Fusion 360 and you get both the design part and manufacturing part in one product. And then there was another great question from Tim about this Inventor and Fusion conversation, where to invest. And Tim answered the kind of the CAM part, right? Inventor CAM remains the same, right? It does a lot of things. It can do a lot of great things, right? But Autodesk is not adding a lot of new functionality to Inventor CAM. While Inventor itself as a design platform remains heavily invested. We're developing Inventor, and even if you look at the last release, the amount of the additions that we have to Inventor itself is huge, right? So Inventor remains great product for larger scale designs. So if you're designing big machines, Inventor is a great tool, right? But on the CAM side, obviously Fusion is our main area of focus, and from design standpoint, Fusion also can do a lot of things. So I would say if your company is using Inventor and you design big machines, this is great. Just stick to it. Okay, so it looks like we don't have a lot of new questions. So let me quickly wrap it up. First of all, huge thanks for joining us today, and huge thanks to our speakers for their presentations. So what I highly recommend you to do is take a look at the what you have, right? Your entitlement, what products do you have access to? Then review the CAM courses that we posted in the chat window. You have all the links. And of course, register to the next mechanical engineering meetup. It's the second Thursday of July, right? And the special topic of the next month is going to be design visualization for mechanical engineers. So we'll talk about different options that we have to visualize and make renderings of your designs. And also we'll talk about VR, virtual reality experiences for mechanical engineers and Inventor users. So this is the topic of the next month. And with that, huge thanks again, and have a great rest of your days. And hopefully we'll talk again in July.
Bye, everyone.
Cheers.
Thank
Bye,
you. Have
everyone.
a good day.
Thank you so much.